Hello class. In this video, we'll be going over the code for performing k-means clustering on movie data. We'll first create a matrix of user ratings. Then we'll choose a k-means model with appropriate hyperparameters and fit it onto the matrix. And we'll finally look at the code that helps us in determining the best possible value of k. First step is to import all the necessary modules for creating a matrix, plots, while carrying out the entire Python functionality required for this assignment. In this code block, we are creating a set of known movies and populating a list called user ratings with movie ratings given by specific users. In this code block, we are transforming movie IDs to index. Now in the next code block, we are populating a list called movie actor map with title name, actor ID, and title genre according to title ID. In this code block, we are creating a matrix of user ratings. And then in the next code block, we are first transforming it into a data frame object and then printing its transpose. Now we'll be applying k-means to the matrix we created. For this specific clustering algorithm, we'll be using mini batch k-means, which is a variant of k-means algorithm and uses mini batches to reduce the computation time while still attempting to optimize the same objective function. We'll first create a model with the parameter being n clusters equals 16, which means we want 16 clusters, n init equals 128, which states that the k-means algorithm will be run 128 times with different centroid seeds, and will give the output with the best inertia, which is a measure of how well a data set was clustered by k-means. The third feature is max iter, which specifies the maximum number of iterations that can be performed over the complete data set. The fourth feature is toll, which specifies the amount of change we are willing to tolerate in terms of inertia. The fifth parameter is the reassignment ratio, which is used to control the function of maximum number of counts necessary for a center to be reassigned. And the last parameter is random state, and it's used so that we can all get similar results each time this algorithm is run by setting the exact same seed. Now we are fitting the data frame into the model. In the next code block, we are forming a cluster data frame with movie ID and cluster number. In this code block, we are printing samples of movies and their information according to different clusters. Now this code helps us in determining the best possible number of k on the basis of inertia. On the basis of the code that we run here, we are forming a data frame with all the inertia values, and then we are plotting them in a line graph.
And now when we look at this line graph, we get some insight into the correct or optimal number of clusters according to this metric, where we see a pretty significant decrease in inertia between k equals 1 to k equals 100, but between 100 to 150, that decrease is much more shallow, suggesting that we start to get only marginal return in clustering when we set k above, say, 150. So maybe a reasonable value of k here is pretty high, maybe around 100 to 120. These are pretty high values for our data set, but this is a case where some sort of domain knowledge is going to be useful. So is 100 separate clusters for these movies reasonable? It's unclear. Maybe you have to do some evaluation or investigation into some of these larger clusters, or see maybe some of these smaller clusters, what they contain. So if we're seeing a lot of clusters with only a handful of movies in them, then perhaps really what we're seeing is there's a distinct set of movies that only very few people have actually watched or rated, and that's what we're seeing these large number of clusters from. But if we look at some of the larger clusters, or we focus on the larger clusters here in this k equals 100 set, maybe we get some more insight into a general set of clustering in the data.